Question number 5. This question is derived from the topic 3, the trick section of your curriculum. Specifically, this is from 3.1 3D geometry, 3.2 triangle section, and the 3.8 solving trick equation section of your topic 3 of the curriculum. So if you look at the question, it says that we have a triangle ABC and the length of the line AB is square root 6, length of that line AC is 10 centimeter, and we know that the cosine of the angle BAC is 1 over 5. So cosine BAC is equal to 1 over 5. So means when we substitute this angle into the cosine data as a data value, the outcome is 1 over 5. That's what that means. So we need to calculate the area of the triangle ABC. To calculate the area of the triangle, we have to use the formula 1 over 2 times base times height. However, with this question, we are unsure of the height of this triangle, right? So this is the height. So we first going to identify our height using the trigonometry rules. Okay, so let's redraw this triangle. Okay, so we have line AC, and we know that this is the height. That means we have a line AB have this side. So this is what it looks like, and line AB is square root 6, right? And then we are not sure of this angle, but when we substitute this angle to cosine, or when we calculate this angle with the cosine rule, we get 1 over 5. Okay, so that means from this angle BAC, or angle A, the height is the same as opposite, right? So using the sine theta equals to opposite over hypotenuse rule, we know that the sine angle BAC is same as height over the hypotenuse square root 6. Okay, so to calculate the height, we have to do a sine BAC, angle BAC times square root 6. Okay, now the problem is we are not sure of the sine BAC. So in order to calculate this value, since we know that the cosine BAC from the question is 1 over 5, we're going to use the trick identity, which is the sine squared theta plus cosine squared theta is equal to 1 to calculate our missing sine BAC value. So let's say sine squared angle BAC plus cosine squared angle BAC is equal to 1. Then the sine squared BAC is same as 1 minus cosine angle BAC square. Okay, so which is same as 1 minus 1 over 5 square. Then we can say that sine BAC is same as square root 1 minus 1 over 5 square. That means this is same as 1 minus 1 over 25, which is same as 24 over 25. And this can be simplified as square root 24 over 5, or we can also rewrite this as 2 square root 6 over 5. Then substituting this back into this equation will give us the height. Then the height is same as 2 times square root 6 over 5 times square root 6, and this is same as 2 times 6 over 5, and this is same as 12 over 5. So we got the height. Then we can calculate the area using 1 over 2 times base times height rule. So the area is same as 1 over 2 times 10 times 12 over 5. Then we get the final answer of 12 centimeter square. Question number 6. So we have a binomial expansion with this question. So means this is actually from topic 1, specifically section 1.9 of the binomial expansion section, or binomial theorem section, you can say. So here we know that when we expand 1 plus kx to power of n, it gives this equation, right? And we do have a restriction for the n and k values. So we do already know that 1 plus kx to power of n is same as 1 plus 12x plus 28 k squared x squared plus and so on. However, when we expand 1 plus kx to power of n using the binomial theorem from your formula booklet, it actually gives us the equation of 1 plus nc1 times k times x plus nc2 times k squared x squared, right? So you can see the difference between these two equations, which means the 12 is same as nc1 times k. The 28 is same as nc2, right? Then we now have two equations to solve two unknown values, right? So if you look at the equation number 1, we actually have two unknown variables. However, if you look at the equation number 2, we have only one variable. So using the combination rule with the NC2, we know that NC2 is same as n factorial over 2 factorial times n minus 2 factorial. And this is same as n times n minus 1 factorial, or we can say n times n minus 1 times n minus 2 factorial over 2 factorial times n minus 2 factorial, which give us a chance to simplify this equation into n times n minus 1 over 2. And this is equals to NC2, means it's also equals to 28. Then we can expand this further as 28 times 2, so we move the 2 to the other side, and this gives us the n squared minus n equals to 56. Then moving the 56 to the other side can give us a quadratic equation. Then factoring this equation out is same as n minus 8 times n plus 7 equals 0, which means n value is either 8 or minus 7. However, since n value needs to be a positive integer, minus 7 is incorrect answer, only n is the correct value. Then since we know the n value, we can substitute this back into our first equation here, okay? Since we already know that nc1 is also same as n factorial over n minus 1 times 1 factorial. This is same as n times n minus 1 factorial over n minus 1 factorial, and this is same as n, right? So nc1 is same as n. That means we can rewrite the equation number 1 as n times k equals 12, and we know that n value is 8 from the previous calculation. That means substituting 8 into n will give us the 8 times k equals 12. K is same as 12 over 8, which is same as 3 over 2. So we can say that n value is 8 and the k value is same as 3 over 2.